we learned in the last class how to write simple program. So here is one example. I want to start here. If I want to write a program to add two numbers together, then I have to write one statement that stores the first number in a memory. You make up any variable named num and assign 23 to it. Rate equal to 35 stores 35 in the second memory. And then you say, add the two memory cells num and rate and store the value in sum. So that's what this means. The equal sign here means store the value of this expression in the variable name sum. Equal signs are not the same as the equal signs in the math. What you have on the left side must be a variable. You cannot write an expression on the left side. It must be variable. Only expression can be on the right side. Okay, if I want to divide, similar to the plus, we have division, multiplication, subtraction, all identified by same math symbols we use. So this is the division. So num divided by val will be stored in ands. If I want to square a variable, I can only write num times num. If I want to square the value stored in num, this is how I do it, and the squared value will be stored in ands. There's no exponent in C++. You have to use multiplication for any exponent. That, like, even if you want num raised to the power 3, then it has to be num times num times num. I can use simple letter as variable like this. N equal to 9 is valid. So in any assignment statement, you would have a variable on the left and expression on the right. Equal sign is what assignment would be written as. The equal sign means assignment. So the num equal to num means copy. If you write any name on the left side, I'm writing on the board. If I want to write val, if I write val equal to num, that would mean copy the value of num into val. Assignment always goes this way. So you can have a variable on the right. That means copy that into this. So if I say num equal to num, I'm copying num into the same variable. What does that do in effect? Really nothing. So you should never write that. And no matter how much I say, students write that in their program. When I run into it, I'll bring it up again. Anyway, that's we went over those, but I wanted to review that. And so these warm-up exercises we have to do next. First one says write C++ statement to multiply three numbers 25, 32, and 62. Okay, can somebody write that? And if anybody has the answer, you can show it to me by putting it against the screen, against the camera, I mean. You cannot use the numbers directly in the program. You must store them in memory cells first. I think it's a fairly easy problem. So I'm going to go over that, and then I will expect you to do the other ones. I'm doing the exercise 1 right now, which is to multiply these three numbers. So the program will be as follows. X equal to 25, semicolon. You need semicolon at the end of every instruction, and you write one instruction per line. So this will store 25 in a memory cell and name it as X. And then Y equal to 32. This will store 32 in a memory cell and name it as Y. And okay, there is one student showing the answer. Bring it down a little bit. Okay, now I can see. Hold on. Right. Okay, you got it. You got it. Yeah, he's using num1, num2. That's fine. And I'm storing the third number Z 62. Okay, one student showed me the answer. He got it right. But this is fairly easy. So we have stored the numbers, and the next thing we want to say is multiply these numbers. You do that by writing the names of those memory cells. Multiply the memory cell X by Y. Asterisk is what you use for multiplication. And Z. Multiply them, and the result should go into another variable. So put equal sign in the front and make up another variable name, ands. Ands equal to this, finish with semicolon. Now it's complete program. Not complete program, but it's the program, the main part of the program. The three values have to be first stored in memory cells, and then you multiply them. Common wrong problem, wrong answer students give me often is ands equal to 25 times 32 times 62. Is it wrong to write this? Well, it's not completely wrong. The compiler will accept it, but compiler will have to translate this to this first. And so you just making the compiler go slower. You know, it has to do additional work. So we don't recommend writing it this way. We basically, computer programming instructors prohibit the students from writing this way, even though it'll work. So you have to write it this way. This is the right way. The individual numbers must be stored in memory cell before using them. So this is not the way you write. Okay, now second exercise says, write C++ statements to double the content of the memory cell named val. So indirectly it means val has some value stored in it. So let me put a picture up. So here is the memory cell. So let's say this is the memory cell that's called val. And it has some number stored in it. We don't know what it is. So I'm making up a number. So let's say I have a 5 in it now. Then the statement you write should change that to double of this number. So it'll have to erase this and put 10 in it. That's the statement you need to write. But we don't know what is there. Okay, I made up 5 just to explain. So we don't know what is there, but you need to replace it with double of the value. So the statement will have to do just that. Okay, let me see if you can figure out how to write that. Okay, see one student, val times x is equal to 2. That's right, but here the 2 is not a variable, it's not a number given in the program. It is, you're using it to double, right? So you can write the 2 directly. You don't have to store the 2 in a memory.
Gotcha.
All right. Only the data have to be stored in variables. So the problem number 1, 25, 32, and 62 are data in the program. They must be stored in variable. To double a memory, when you have to multiply by 2, that 2 can be directly used in the program. You don't have to store that in the memory. Okay, one student had it right. Anybody else? So the student who finished number 2 can go on to 3 and 4. Oh, there's one answer. Michael. I can't read what's on the left. Is that ands? Yeah, I think you have ands equal to val times 2. Okay, that's not right. I'll explain in a second why it's not right. See if you can figure it out. you're not achieving the goal. The goal is to replace the value of the memory cell val with double of the original value. And you're not doing it. So Michael, your statements do not change the value of the variable val. It's not changing it. Okay, you have a better one? No, yeah, now you got it. You got it now. Very good. That's it. Okay. Yeah, Michael, you got it. Okay, I'm seeing someone else now. I'm not seeing, move it up a little, up, no, further up. I only see XYZ. There's no XYZ involved in this. You may be showing the wrong page. There's the variable name involved here is val. Okay, who is this? Yeah, that's right. I'm seeing. Yeah, you got it. I see it. You got it. Very good. That was Christine.
I have a question.
Yeah.
Do I have to use two when solving it?
No, there are
Okay.
different ways to achieve anything. So if you have another way, you can present that.
Can I tell you what I put?
Yeah, you can show me what you have.
Um, I didn't really do it. I did it in my head, but I put val is equal to val times val. That replaces the value of val.
That's not doubling, that's squaring, isn't it?
If val times val would be doubling it though.
Val times val will be squaring.
You're right. You're right. You're right. You're right. You're right. My fault.
Okay, we need to double, not square. Okay, let me explain. I have, I'm going to explain the wrong answers first. One student showed me, he did val on the right side, val times 2. That's correct. Val times 2 will be doubling it. But then he assigned it to ands. If you do that, then what you're doing is whatever val has, you're multiplying it by 2 and putting the result in ands. Okay, so ands has double of the value of val. The val itself still has the same original value, whatever it was. You didn't change it. You only put the new value in ands. So this is not right. This will be correct if you're computing the value of val. If you're computing twice the value of val and you need to put it somewhere else, then this is valid, but that's not doing the job. Our task is whatever val has, if it has a 5, we need to replace it with 10. So the correct way to do it is val times 2 should go back in val. Remember, we are not writing mathematical equation. We are writing assignment. So this may be wrong in math, but it's a valid assignment statement. This says multiply val by 2, put the result back in val. So that will erase the original value of val, put the new value in. Semicolon will make it complete statement. So is this the only way? Not really. To double the value, you can write in another way. Val plus val will be also doubling, isn't it? So add val to itself and put it back in val. So this is again, it's a C++ statement. It's not a math statement. So it basically says add val to val itself, which will be same as doubling it, put it back in val, then that'll change the value of original value. Warm-up exercise 3 is to compute this expression 5x plus 2y plus 20 for the values of x equal to 7 and y equal to 18. So the 7 and 18 are data for this program. So they should go into memory first. And then you use them to calculate this expression. So anybody has an answer? I want to see that. Others keep working. All right, one student is showing me, and it's two of you, okay. Okay, I don't see your name here, but yeah, one of you is right. Yeah, the other student is showing it sideways. Can you turn the page? Okay. Right. Okay, both of you are right. But your statements, one of you don't have the semicolons at the end. Also, you didn't write one statement per line. Other than that, you're right. The other student is Alexandra. Alexandra has the program right. Very good. Okay, two students have the program right. Anybody else? There are 28 of you out there. I expect more than two students to be able to do this.
I have a question.
Sure.
Is there like an order of operations in this? Like when it's like computing everything, does it do it correctly, or do you? Because I did it that a different way because I wasn't sure.
Okay, there is an order. In the order in which you have written the statements, that's the order system is going to carry them out. It'll do the first statement first, second statement second, in that order. Okay.
Okay.
Professor, I'm showing mine. I don't know if you can see.
Okay, Vanessa, I see. Yeah, you got it right. Vanessa got it right. Excellent. Okay, that's three students with the right answer. Anybody else? All right, I'm going to show you on this board. So I need to store the 7 and 18 in memory cells. I can use the same name X and Y. So X equal to 7 semicolon, Y equal to 18 semicolon. These two statements store those data in the memory. And then I need to multiply 5 by X, 5 times X. So I can write 5. Writing it as 5X is wrong. That's how you'll be write it in algebra, but not in C++. Every multiplication should be clearly identified as multiplication. So I need an asterisk for multiplication here. Plus 2 times Y plus 20. This will calculate that expression. And then I need to assign that to a variable. So make up another name, call it ANS if you like. And now the value of this expression, it basically says multiply 5 by X, add it to 2 times Y, add it to 20, and then put the result in ANS. All that is said right here. So that's all you need to write. Compute that expression and put it in some memory.
So, Professor, I had a question.
Sure.
So, in the exercise 1, you said you couldn't just use numbers alone and put, for example, answer equals 25 plus 32 plus 62. You said you couldn't do that. But for this problem, the 20 is alone. So I didn't know if whether or not you had to create another variable for 20.
I got you. I understand your question. See this expression. So things in this expression are not data. That expression is the expression, basically the expression you need to evaluate, right? The data are the 7 and 18. It's basically what I mean is, if you're going to reuse this program to calculate value of this expression for another value of X and another value of Y, that can happen, but the expression itself is not going to change when you need to redo this program. The expression itself is not really data. Okay, so everything in that expression can be directly used, like the 5 and the 2 and the 20. They are not data, they are part of the expression, right? So I can write them directly. I don't have to store them in the memory. But the 7 and 18 are the values of the variable x and y. They are the variables. And so, think about this as an algebra problem. If I ask you to find the value of the expression for 7 and 18, I can ask another question that says find the value of the same expression for 9 and 10, x equal to 9 and y equal to 10. So basically the x and y are the variables that can change, but the coefficients in the expression are constants for this programming problem. Okay, if they change, then the entire problem is changing. So they're considered to be constant for the problem. 7 and 18 are the variables. That's why I can use the 5 and 2 and 20 directly in the expression.
Thank you, Professor.
All right, so you have to identify the variables. And in the first program, in this program, problem number 1, 25, 32, and 62 are the variables. They are the numeric data for the problem. So they're considered to be variables. So whenever you're working with an expression like this, everything involved in that expression, the coefficients are constants. You can directly write them, okay? It'll be clear as to what is data and what is constant, usually. Okay, so exercise 4, let me explain exercise 4. It says write statements to swap the values of the variables dab and doc. So indirectly it means dab is a variable, means dab is the name of a memory cell. So dab is a memory cell. Doc is another memory cell. And so indirectly it means they have some value. We don't know what they are. So let me make up some values like 10 and excuse me, 10 and 7. So if these are the values, then after your statements are executed, you should have 7 here and 10 here. Okay, that's what our goal is. But the 7 and 10 I made up. The values are unknown. So you have to write the statements to achieve this task, even though you don't know what values are there. So the statements you write, after they are executed, the values should be swapped. Okay. DAP should have whatever doc had, doc should have whatever DAP had. So that's our goal. And see if you can write that. So anybody, if you have the answer, go ahead and show it to me. Okay. Move it down a little bit. Down. Okay, now I see it. No, that's wrong. Let me explain. Another student is showing something similar. Nope, that's wrong also. Okay, so let me explain on the board what was wrong with your statement. One of you showed me, or both of you actually, 2 of you showed me solution that start with the statement dab equal to doc. Okay, if you write dab equal to doc, you're saying copy doc into dab, and that means the value of dab is erased right there. You lost dab. Now you don't know what it is, and you can't put it in doc. So this is wrong. This will copy the doc into dab, but dab has a value that should be preserved, and it's already erased by this statement.
So I have a question. Are we now supposed to give them both values in order to do it appropriately?
No, they already have values, and you should not assign any value to them. If you assign another value, you're erasing the original value. Okay. you need to work with the original value. So you should not assign any value to that.
So instead, do we create two new variables?
You can create new variables if you need, yes. To achieve this, if you need to create other variables, you can do that. Okay, I see a solution. Your first statement says dab equal to something. If you say dab equal to something, then you're erasing dab, right? If you copy something into dab, you're erasing it. So that's not right. I think you meant to write them in the reverse order. You have them in the wrong order. In other words, you have dab equal to bad or something. That's what I see, bad. You're saying copy bad into dab, but if you do that, you're erasing value of dab, right? That's wrong. That was Michael. Michael, that was not right. Dab equal to anything. The first statement says dab equal to something, and that right there erases dab. So that's not right. We don't want to erase anything. So keep working on it. Anybody has a solution? All right, yeah, that's a little bit challenging. So let me go ahead and explain that. So these two memory cell, dab and dog, have some values, and we need to exchange them or swap them, but we don't want to erase any of them. So dab and dog. So what you need to do is, before you can copy doc into dab only after saving dab somewhere. So I can copy the dab into another variable name. So copy dab into T, make up any other name. So this is what I'm doing first, copying dab into T. So that'll be T equal to dab. The assignment goes in this direction, okay? So new variable goes on the left. And if I write dab on the right, then I'm saying copy dab into T. Okay, so after that, I can now move doc into this. Sorry about that. So I'm now copying doc into dab. So that'll be dab equal to doc. So this will copy doc into dab this way. And after that, I copy the T into this by writing doc equal to T. Okay, they have to be in that order. You cannot change the order. So first I'm storing a copy of this somewhere just to save it. After that, copying doc into dab, and then copying T into this. It has to be done in that order. These three statements will do the job. So no matter what the values of dab and doc are, they have been swapped by these statements. Okay, so this swapping business will come into play in larger programs. So that's why I wanted to have you do that at this point. So that basically finishes our section 2.1. I'm going to move on to 2.2. Now I remember I did say in the last class that we'll be running program in this class, but unfortunately I'm not ready. I have to get my Windows computer brought up here and set it up for to have the meeting on that. and I had some issues doing that, but now I have longer time, so I will have it done ready for next class. And it seems appropriate to do this in the next class. Oh, Alexandra, you have a question? Go ahead.
Yeah, sorry, I just had a quick question about the exercise 4. If we did a variable for dab and then a variable for doc, would that be kind of frowned upon since we don't need the extra variable?
Okay, you mean copy dab into a variable and doc also into another variable? Is that what you-
Yes.
Yeah, okay. Yes, there is a way to write it that way too. And that's correct too. So I know what you're talking about. So I'm going to write that on the screen for you to see that. Hold on, let me get rid of this thing. Okay, so instead of this, you can, what Alexandra is suggesting is using two variables to copy that to dab and doc into other variables. You can do that. So this is another version of the program, x equal to dab, semicolon, y equal to doc. You're saving both in two other memory cells. And now copy into doc, whatever dab had is copied into X. So now you can say doc equal to dab. They were all saved already. So you can copy the dab into doc now, and then do dab equal to y. Y has the copy of doc. Y has a copy of doc. So now copy y into dab. So this is also correct. Nothing wrong with that. But when you do it this way, it's kind of, easier to follow. You're saving one of them. Only one of them needs to be really saved somewhere. Then you're copying this, erasing the dab, and then saved value goes in here. It's kind of easier to follow, but there are different ways to write like this. There are other ways, but you have to go for the easiest, the one that is easiest to follow. So it is correct to answer the question, Alexandra. That is correct.
Thank you.
So moving on to the next topic, section 2.2. In fact, if you finish 2.2, you will be better prepared to write your program. So it will be better to run the program after learning this topic. So anyway, let's get started with the variable types. Variable types means your variables that you introduce in your program, like this dab and doc and x and y we introduced. They all have to be declared in the program as variables of a certain type. And so variables cannot be just used in the program. They first have to be identified as what type. The system needs to know that first. So therefore, we need to understand how to determine variable types. So that's what we're going to do in this section. First, before we go into the variable types, let's understand the rules of the variable. Remember, I said you can make up any name that will be a variable name. Well, there are some rules though. The variable names can only be made up with lowercase alphabets and numbers. The normal numbers 0 through 9 can be used. More than one digit can be used if you need. But you can mix letters and numbers, but lowercase alphabets only, not uppercase. Only other character allowed, other than numbers and letters, only other character allowed is underscore. You cannot use any other character. No mathematical symbols or other special characters like $, none of that can be used in the variable. Alphabets and numbers, underscore, that's about it. The first character must be alphabet. You cannot begin the variable with a number. And also the keywords. There are keywords in the language and you cannot use them. You haven't learned any keywords yet, but as we proceed, we will be learning keywords and they cannot be used as names, variable names. So let's go to the examples of variables. If I want to store 75 in a memory cell, I make up this name num1 and assign 75 to it. And that's how we do it. That's correct. This is a statement in the program. When the compiler translates that, remember, compiler has to translate your program to machine language before the program can be executed. So after you write the program, you will be accessing compiler to translate it. And compiler, when it translates this program, it will translate the 75 to binary code. As I explained before, only binary code coded number can be represented inside the memory. So it'll translate that to binary code, and then it'll store that in the variable called num. So this is what you will have in a memory cell, what is shown here in this picture. The circuits will be turned on and off according to the binary code of that number, and that's what will be stored in the memory. But in our program, we can write this. We don't have to write binary code. So we learned the binary code to be able to understand how things are stored in memory, and also we need to know binary code to be able to determine how many bytes of memory will be needed for our number and things like that. So for those reasons, we learned about binary code, but we don't have to convert the data. The data will be converted by the compiler to binary code. So moving, so the variable names have to be according to the rules that we learned on the previous slide. And here are some variable names that are correct. X is a valid variable. Total money, notice the underscore. I wanted to combine the words total and money to make a new variable, but you cannot use blank space. So to separate the two words, I have underscore. That's how you use the underscore when you need to combine two words into a variable name. Sum is a valid variable, num2 is a valid variable, char10, double digits can be used. First val, these are all valid variables. Fourth num is invalid. Why? Anybody?
Because it starts with a number.
Right, starts with a number. Very good. This is invalid because the dollar sign cannot be used anywhere. Special characters cannot be used. Same thing here, dot send, that has a send symbol, which is not allowed. X plus Y is a invalid variable name because of the plus sign. Okay, now let me go to the board and explain something about the variable names. So let's say I wanted to add two numbers. So the two variables X and Y have numbers stored in them, and I want to write a program that will add them. So I wanted to write Z equal to X plus Y because, hold on, Sherry is, someone just came in. Okay, so I want to add two numbers that are stored in X and Y and store the result in some variable name. So this is what I should be doing, Z equal to X plus Y. X and Y have the numbers already stored, so I want to add them and put it in Z. But instead of writing the statement this way, I make the mistake of writing X plus Y on the left and Z on the right. This is wrong because this says assignment goes this way, right? This way. So this is not what I wanted to do. This is correct. Add these two and put the result in Z. That's correct. Instead of writing it that way, I wrote this. So that means it's wrong, but what do you think the compiler will identify this problem as? It's not going to know that you swapped these two things and you have it the wrong way. It's not going to find that. It's going to recognize this as a problem of some other kind. How does it? The compiler is trying to translate this, and it will not be able to translate this particular statement. So what do you think the compiler will complain about? Anybody?
Would it complain about the x plus y?
Right. What do you think it'll say?
That's a syntax error because x plus y is an invalid variable name.
Exactly. Very good. You got it. It will try to identify this as a variable because on the left side, you're supposed to have variable, and this doesn't qualify to be a variable. So it'll say invalid variable. So that's why, sometimes what the compiler says doesn't really tell you exactly what the problem is, but you need to use that compiler's complaint to figure out what actually went wrong. It will say invalid variable because it will try to identify x plus y as a variable, and it doesn't qualify. So the real problem is you have them swapped, and the compiler is not going to know that. So this is a good example of why compiler cannot tell you exactly what the problem is, but it will tell you there is a problem here, right here. So that using that, you had to figure out what the problem is. This is exactly why they didn't allow plus symbol in a variable, because this is wrong. This is not intended. And if this is allowed, if x plus y is allowed to be a variable, then this program will run and produce wrong answer. This is not what you intended. So to prevent that from happening, they decide not to allow these other characters in variables so that when you make a mistake like this, it'll be identified by the compiler as a problem. Here's an example of compiler complaints, compiler telling you error messages, and you had to figure out what the error is. You're on your own, basically. The error message doesn't usually tell you exactly what the problem is. Moving on, always use meaningful variable names when you make them up. So, for example, if I'm using a variable to store operating cost, I cannot use operating cost as a variable with a blank in it. Blank is invalid because it's basically a special character. No blank can be there. So I can abbreviate that word and write op cost, or I can use an underscore and make this entire word. I can put an underscore in the blank and use that word. There's no limit to how big the variable can be. It can be long, but you don't want to use long variables. So instead, abbreviating the name into opcost might be a better idea. If you want a variable to store ID number, then ID num is a good name for that. If you want to store customer name in a variable, use customer or name as the variable name. So meaningful variable names will be a good idea because you yourself can keep track of what variable has what data, and it is helpful. Okay, in C++ statements, you must have a semicolon at the end. Every C++ statement must have semicolon at the end. Assignment statements will have a variable on the left and expression on the right. Only a variable name can be on the left. The equal sign here means assignment. It doesn't mean equal sign in the math. Expression on the left side will be computed and it will be assigned to the variable on the expression on the right side will be evaluated. The value will be stored in the variable name found on the left. So let's look at some valid examples. val2 equal to 35. This is assigning 35 to the memory cell. Operating cost equal to A/B times C. So we have an expression on the right, and it'll be computed. The value will be stored in operating cost. Profit equal to revenue minus costs. Dollar equal to cent over 100. Customer equal to J. The J is in quotes, and so this is valid. So let me go to the board and explain something. If I write val equal to, I wanted to store the character J in val. I forgot to write the quotes. So what would this be interpreted as? Anybody?
Did it give you an
Invalid.
error?
It's not going to recognize that as an error. It doesn't know. It is a valid statement, isn't it?
Oh yeah, you're right.
Yes, it's a valid statement. What would it interpret this as? It'll interpret J as a variable now. And it'll try to copy the value of J into val. That's what this means, right? Copy the value of J into val. That's how it'll interpret. So you forgot the quotes. That was the error, but compiler is not going to tell you that. Compiler will only, it'll give you a message that this J has not been declared. That's the message it's going to give you, because if you didn't intend J to be a variable, so you didn't write a declaration. Declaration is something we'll be discussing in a few minutes. Declarations are supposed to be written first, and you wouldn't have written J as a variable. You wouldn't have declared it as a variable. So the error message is not going to correspond to what your mistake is. Your mistake is missing quotes. That's the reason why they require quotes around data. If J is to be a data, you put quotes around, then J itself is a data, not a variable. If you don't write quotes around a variable, a name, any name, then that becomes a variable name. This will become variable name. So to distinguish variable from data, they decided to add quotes for the data. You can only use single letter as data, like J. So you cannot use something like Jacob as data and put quotes around it. If you have more than one letter in your data, then that's called a string. And we are not going to be dealing with strings in this class. You'll be learning that in the next course if you're going to go on into the next course. But here in this class, we cannot handle names as data. We cannot handle that. We can only handle single letters with quotes around. Single letters with quotes around can be data, but no more than single character can be handled. Okay, moving on. Data types of variables. The variables that you use in your program must be identified as certain data type. So you need to first decide what that data type would be. Each variable, what data type each variable would be, and then you need to make a statement in the program telling the system exactly that. So first we need to learn how to identify that. So let's see. You decide exactly what data is going to go into that memory. So let's say you are trying to store an integer value in a variable, then the variable will be integer type. So the data types are three. We learned it before. The three types of data we have learned are float type, integer type, and character type. Those are the three types we have learned. There will be other types we'll be learning later. So you decide exactly what type of data is going to go into that variable, and the variable is going to be of that type. So data type of a variable is the same as data type of the value that's going to go into that variable. And once you determine that, you need to identify that by using, you need to identify those variables as of those types by using some keywords. The keywords are float, int, and char. So float, the keyword float will tell you the system that the variable is float type. Variable is float type means it'll hold only float type value. The declaration statement in which you use int as the keyword will say the variable is int type, and variable is char type if you're going to store a character in it. So once you identify that data type, you would write a declaration statement at the top. It will look like this: float upcast. This means upcast will be a variable that will hold float type value. That's what you're saying. And this statement has to go at the top of the program before you use the name upcast in your program. So that's what we call declaration statement. So every variable you use will have to be declared at the top of the program. So we normally write these statements at the top of the program as a rule for the programmers. That's how it should be. Even though throwing these in anywhere in the program is acceptable, any reader of the program would be better understanding the program if he or she can see all the variable names and their types right at the top before reading the rest of the program. So you're all advised to do the same in your computer programming projects. Int ID num says ID num will hold integer value. Char cval says val is going to be character type. It will hold characters. So now you have learned three keywords here: float, int, and char. So these keywords cannot be used as variable names. You have to make up some other names. These keywords must be avoided. That was the last rule that we learned in the rules of the variable names. The keywords of the language cannot be used as variable names. So here we are with three names, three keywords. There will be other keywords you will be learning, and you must make sure your variable name is not one of those. Okay, so some more examples. I can declare many variables in one line like this: float, upcast, comma, val1, comma, val2, and then semicolon. Even if this list has to be longer, you can do that. If the list has to break up into 2 lines, you can do that. The semicolon will identify the end of the statement. So here's another statement: int, and I have multiple variables. The list is longer, so I divide it into 2 lines, and I put semicolon here at the end. And this semicolon identifies that the previous line and this line are together as one statement. So as long as your semicolon is in the right place, you can break up a statement into several lines if necessary. Char, val, and ch1, 2 variables are recognized, declared as char type. All right, so here is a question that says, are these valid variable? Are these statements valid? So if anything is invalid there, you need to explain what it is. Float fifth value is invalid because the variable name fifth value is invalid. It is beginning with number. Int float is invalid because you're declaring float as a variable name. Float is a keyword in the language. You cannot use it as a variable name. Characters val21, val22, invalid because you don't have a keyword. The keyword to declare a character type data will be char, not character.
Professor, I have a quick question. Yeah. So what's like, if you don't make these like declaration statements, what happens like when you're using these variables? Does it like change anything?
Yeah, that's what I was saying in this on the board. Let me go back to the board. See, if you write this statement here, and if this j was not declared at the top as int j, if you don't have that, it'll say this variable is not declared. It says not recognized because it's not declared. That's what it'll say.
So if you do have it, it's going to convert it to whatever the data type is.
What do you mean convert? If you
like, yeah,
if you
exactly.
declare j as an int type, then it'll only hold integer type value.
Okay.
And j is good for holding integer type value. That's what it means. And if any variable is not declared before it's used, the compiler will say this variable is not recognized because it was never declared. Okay, so all variables must be declared. Okay, when you declare a variable as certain type, then only that type value can go in there. So if I declare a variable as int type, I can only store int type value. If I declare as char type, I can only show char type value. So what will happen if I try to store a different type value, it'll be converting it. Those conversion details are coming up in the next section. So let's wait for that. So right now you just have to remember only of that type value can go into that variable, the type you declare. So here's a little program. I declare upcast and val2 as two variables to store two numbers. And I store the number 560 in upcast, 8 in val2. But this must be there before these two, okay? The order matters. If you don't have the int upcast val2 before the use of these variables, compiler will complain. Because compiler will be going in that order. It'll execute the first line first, and it has to see that declaration before the variable is used. Another example, I want to store the character and ampersand symbol in the memory. Then I have to declare a variable cval, and then cval equal to ampersand. If I don't, you need both statements. So let's say one of your homework questions says, write the statement to store the ampersand symbol in the memory. Then you have to write both of these because the declaration is required part of that. If you just write this, that's not quite right. You may get partial credit if it is homework question, but not full credit. Okay, so can we declare and assign at the same time? Yes, you can. I'm declaring upcast and assigning 560 to it, and val2 and assigning 8 to it, all in one line and semicolon. That's acceptable. In fact, we do that all the time. It's so convenient to assign and declare at the same time, and we do that all the time. So that second statement we did here, char cval and cval equal to and symbol can be written all in one statement. You have to have a blank here, but the blank after the cval equals and equal sign is not necessary, but we write it for easy readability, but not required. This space is also not required, but this space is required. Otherwise, those two will join into one word, and the whole thing will be recognized as one variable. And this is the reason why blank is not allowed in a variable name. If blank is allowed, this whole thing will be accepted as a variable instead of declaration. That's why blank is not allowed. Okay, moving on. Now, I said earlier, we saw how to write program, but we never wrote a statement that will display the value, display the answer on the screen. To display the answer on the screen, this is a statement, cout. Cout means C language output. Remember C++ evolved from C language. And so this is coming from C language, C output. So it's a keyword in the language. So again, that's another keyword. So you cannot use it as a variable name. And you need to put two inequality symbols. We read it as arrow, but it's actually two inequality symbols in that direction, not the opposite way. And then you put a variable on the right. It means display the value of this variable on the screen. That's what it means. So it'll put the value of that variable on the screen. So here's an example. Suppose that ans has a value 14. Then if I execute cout ans, then the value 14 comes up on the screen right there. It will not do anything else. It will just display the value of that memory cell wherever the next writing can be done. So if there is already some display on the screen, this will go right next to it. So it doesn't know It doesn't even go to a new line. You have to tell it to do that. If you want to go to a new line, you have to write in your program that's a statement that says go to new line and write this. So for everything you had to provide instruction. So this will go right where the cursor is. So if you want to do more than that, better than that, then you have to add more things. So I'm using this example to illustrate that. I have a statement. This is a program. M is assigned to 5, N is assigned to 2. Then I write cout M. That means display the value of M. And this says display the value of N. So that would be 5 and 2. So even though these two statements are on separate lines, don't think that the output will come up on separate lines. This says display the value of M. It'll display that first, that's 5. And then this will display the 2 right next to it, because you didn't say go to new line. So if you want to go to new line, you have to say that, and we're going to see how to do that. So the system will follow your instruction exactly as is, and this is going to produce 5 and 2 together next to each other, and anybody reading it will think that it's 52, but it's not. It's 5 and 2. So we have to properly display it to make the meaning come out right. So that's why we have some other things in the language. The ENDL stream manipulator, ENDL will tell the system end line, basically. It means end line. In other words, it will say go to new line. So you need to write it as cout ENDL. Cout ENDL means print end of line. It essentially makes the system, the cursor on the screen go to new line. So you should interpret this statement as new line statement, saying to the system, you're saying go to new line, but it always goes with the cout. In other words, you're saying print ENDL, that's same as saying go to new line. So now we can make the system write the two numbers on two separate lines by writing this: int m equal to 5, n equal to 2, cout m, and then cout ENDL, then cout n. So that way your display will be now 5 and 2 on two separate lines. Okay, so do we have to write these couts in 3 different lines? We can actually combine them in one line like this: cout m, but you had to write those arrows: cout arrow m, arrow ENDL, arrow n. That says write the m first, then go to new line, then write n. All that is set right there. Okay, so here's another example. I want to write a program that will multiply these two numbers together. Okay, then float. They're not, obviously these numbers are float type, so I need float type variable. Float num1 equal to this and num2 equal to this. And in the same line, you declare the third variable to store the answer. Every variable you use must be declared. And ans is going to be float type because it is going to hold a float type value, the product of these two numbers. So you have to figure out what type of value you need to store and declare that data type. Then you write ans equal to num1 times num2. So that's going to multiply the two numbers. Now you're saying cout the answer and then go to new line. Now, why did I put go to new line at the end? Because when you display, when you write a program, when the program is executed, right after executing a program, the system will put some messages right after the output. So you don't want those messages to come right after your data, your output. So you want your output to be clean, very easy to read on one line, one separate line. So if you throw in this ENDL, then anything system writes after your output will go on a new line. So it won't be part of your output. So always it's a good idea to throw in this ENDL at the end of your output statement. So keep that in mind when you do your programs. Okay, so I'm going to quit here. We are almost out of time. Any questions so far? Feel free to ask. Today's assignment included some questions in 2.1, and I assume that you have already uploaded all of them. Any issue, any problem, you can bring up here. Everybody is okay in uploading your homework?
Yeah.
Professor?
Yeah.
I don't have the book yet, so I couldn't do 2.1.
All right. Yeah, I understand. This is one of the reasons why I sent that message before the beginning of the semester. About 2 weeks before the beginning of the semester, I sent a message asking everybody to order the book, and I gave the information on how to order that. Because if you have ordered at that time, you would have had it on time. Yeah.
I was just gonna mention that the trial actually is like 30 days. I haven't bought the book yet, but I've been able to like access the other chapters. So if you go to the website that you gave us to buy the book online, you would still be able to access it at this point. And I guess being that I don't know,
Okay.
that's how I'm able to use the book up until I can buy it.
Okay, as a trial on a trial basis. Okay, then why don't you do that? They apparently allow you to access the book, the online version of the book, for temporary short period of time. Okay. Who was that? Who had the problem of getting the book? Ismail? Is that Ismail?
No, Professor, it wasn't me.
Okay, who was that? You can access it that way. Otherwise, if you want to get direct access, I can, I have permission from publisher to allow the students to access my chapter 1, but I don't have a permission for chapter 2. So I don't want to violate any of the rules of the publisher, but I can do this. I can send you an older edition of chapter 2, and you can use that. It has the same questions, but the explanations are not perfectly, as good as the new version, but you only need the problems. So that older version will give you all that. Okay? Whoever had the problem, send me a message requesting the older edition of chapter 2. So, so today you didn't submit the 2.1 problems because you didn't have the book. So I'll do this. You asked me, request the book, chapter 2, old edition. I will send it to you. And after that, you give me the new version of the entire program. I can only receive one document having all the solutions, including new ones, the 2.1, section 2.1. Then I will upload it for you. I'll remove the previous one and upload it for you. Okay, so I'm giving you extended time because of the problem you had.
Okay, thank you.
I don't know who it is. Is it Alexis?
Yes, sir.
Okay, you had the problem. Okay, then I'll expect a request first. And once I receive the request, I will send you the 2.1. Okay, I'll have chapter 2, all of chapter 2. And then I will upload the assignment for you if you send it to me right after. It has to be in by Friday, then I'll be able to upload it. Okay.
Okay, no problem. Thank you.
Any other problem? Anybody else?
Professor, let's say that I did like submitting the homework, it didn't confirm it. So it shows that I didn't give it in, but I did the homework. So let's, I don't know, like if we could fix that, but if anything, how do I submit it if it's late? It doesn't let me submit it.
Yeah, if it is late, it won't allow you to upload it. Hold on, I can take a look. Ismail Chamorro, right?
Yeah.
Okay. Let's see. 271.
I think I just might have forgotten to click the submit button at the end of that. But if I did the homework.
Oh, you may have forgotten to click the submit button.
Yeah,
Get that?
yeah. I think I just had like in mind that I did it, and then I just closed the window thinking that I did submit it because it shows that I didn't submit it.
All right, I'm going to
Yeah, I almost did that last night. It was like 4 in the morning, and I remembered I didn't press confirm. Because once you press confirm, if you don't press confirm, it doesn't submit it fully.
Yeah, the confirm has to be pressed. Yes. All right. I'm going to Ismail. I'm going to allow you a chance to submit that. So what I can do is you send it to me by email, attach it to an email. I'll submit it for you.
Okay? Yes, Professor. Thank you.
Okay. Okay, so I don't know. Normally, you're not allowed to submit anything late. Now, these students had some specific problems, and so I'm allowing them to submit late. Ordinarily, you should submit them on time. And another thing I need to remind you is this. When you look at homework 3, you see the problem. It tells you what problems must be submitted as part of this. This is the correct number. You see assignment anywhere else, you may see some assignments on the presentation slides. They're not correct. They were made a long time ago. They have been changed now completely. So do not follow that. The course calendar is somewhat useful, but it's not going to be perfectly accurate because always what topic were handled in the class is changing all the time. So this is the most accurate information as to what you need to submit.